Hello everyone. In this video we're going to be dealing with an exponential expression. We have 2 to the power a equals 3 to the power b, and we're supposed to evaluate a to the power a plus b divided by b. I'll be presenting two methods. Let's start with the first one. So for my first method, I'm going to set both of these equal to x. Any variable is fine. And then take a look at each one of these. 2 to the power a equals x. Let's go ahead and ln both sides. Ln is, by the way, the natural logarithm. So we're going to take the natural log of both sides. So it's going to be ln 2 to the power a equals ln x. And that implies a times ln 2 equals ln x. And finally, we can write the a as ln x over ln 2. You could also take the logarithm of both sides with base 2 and then use the change of base formula. You'll get the same thing. Now, similarly, we can write the 3 to the power b is x as x, and then take the natural log of both sides. Natural log of 3 to the power b equals the natural log of x. From here, we get something similar. So we can move this b to the front and write it as b times natural log of 3 equals natural log of x. And then from here, b just becomes ln x over ln 3. So we got these two expressions for a and b. And remember, we're trying to evaluate a to the power a plus b over b. So let's go ahead and evaluate the exponent first. What is a plus b over b? So we were able to write a and b in terms of x. So let's go ahead and plug them in. A will be replaced with ln x over ln 2. ln x over ln 2. And b will be replaced with ln x over ln 3. And that will be divided by b again, ln x over ln 3. So let's go ahead and simplify this, make it as simple as possible, and then use it as an exponent here. Okay? So first of all, notice that we can take out ln x. So that's nice. And then inside the parentheses, actually, let me go ahead and write it here. Inside the parentheses, we're going to get 1 over ln 2 plus 1 over ln 3. So we kind of took out the ln x as a common factor. And then at the bottom, we have ln x over ln 3. So at this one, we can go ahead and cancel out ln x, and obviously x does not equal 0 as long as a and b are not equal to 0. But b can't be 0, because if b is 0, then we're dividing by 0, which is not allowed. So we can cancel out ln x. Okay? Great. So now we can go ahead and make a common denominator here. ln 3 plus ln 2 divided by ln 2 times ln 3, and then this one is 1 over ln 3. We're going to flip and multiply ln 3 over 1. ln 3 cancels out. We end up with ln 3 plus ln 2 over ln 2. Now we can go ahead and combine these two things. Remember the property of logs. If you have log a plus log b, you can write it as log a times b, as long as a and b are both positive. So from here, we can write the ln 3 plus ln 2 as ln 3 times 2, which is ln 6, and just divide it by ln 2. So that is the exponent. Now we have to use 8 as a base. So we're trying to evaluate 8 to the power a plus b over b. And this is a plus b over b. We just evaluate it. So the answer is 8 to the power ln 6 over ln 2. Now at this point, it might be helpful to write this using change of base formula, but backwards. So this can be written as log 6 with base 2, because 2 goes here and 6 goes here, remember? So now this becomes 8 to the power log 6 with base 2, but now 8 can be written as 2 to the third power. So this becomes 2 to the third power to the power log 6 with base 2. Now we're going to move the 3 outside. So this becomes 2 to the power 3 times log 6 with base 2. And then obviously we want to go ahead and bring this over here, because another rule for logs is you can make it a power. So this becomes 6 to the third power, log of 6 to the third power with the same base. which is 2. And now when these two bases are the same, the answer is going to be the exponent, which is 6 to the third power. So this is equal to 6 to the third power, which is 216. Okay, that is the first method. And again, the formula or the log property that I used involves this. A to the power log b with base a is equal to b because these two bases are the same. Okay, let's go ahead and take a look at the second method real quick, and then we'll finish up with that. Obviously, and a lot of times this is true, the second method is actually a little smarter. You know, it's a better method, or it's shorter, whatever. So here's what we're going to do. First of all, we're going to raise both sides to the power 1 over b here. The purpose of doing that is to isolate the 3 and also to get 2 to the power a over b. That's what we get from here, 2 to the power a over b. Not only that, it also equals a number. Great. Now, how do you use that? We're going to go ahead and use that here, but let's go ahead and manipulate that a little bit first. A to the power a plus b over b. Now, this fraction can be broken down into the sum of two fractions because of the numerator. So we can write this as a to the power a over b plus b over b, which is 1, and then it becomes a to the power a over b times a to the power 1, which is 8. Okay? Now, how am I going to associate it with 2 to the power a over b? Well, 8 is just 2 to the third power, so we can write it as 2 to the third to the power a over b times 8. And then we can go ahead and switch these around because they're going to be multiplied. So 2 to the power a over b is equal to 3 from here. And if you replace that with 3 to the third times 8, the answer will be 27 times 8, right? And 27 times 8 is going to equal to, guess what? 27 times 8 is just going to equal 216 as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.